Hello and welcome to Lesson 11.2, Arcs and Chords. Today's objective will be to apply properties of arcs and to apply properties of chords. So we're going to talk about what those things are in just a moment. First, begin by doing the warm-up. Make sure you start the lesson by doing this warm-up. It will help you understand some of the skills we use in the examples, so make sure you take time to pause the video and do these warm-up questions if you haven't already. When you're ready to continue, if you've paused it, click play, and these are the answers we should get. For number 1, we should get 30%. To do this, we call it the is over of method. Take the number after the word is and put it over the one following the word of. 18 over 60 is 0.3 or 30%. To do a number that is 44% of 6, we just multiply 6 by that percentage. 0.44 times 6 is 2.64. So we're going to do the same kind of thing here for number 3. To find the measure of this angle, we need to recognize that this wedge of your circle here is 29% of the full circle, so this angle is 29% of 360 degrees. 29% of 360 is 104.4 degrees. Alright, let's talk about some of the terms in our vocab today. A central angle is an angle whose vertex is at the center of the circle. And then an arc is an unbroken part of a circle consisting of 2 points called the endpoints, all the points on the circle between them. Okay, so just to kind of talk about this here, we have a central angle ABC in this first diagram. Then the arc would be this arc consisting of the part of the circle between A and C, not a straight segment, but that curved part of the circle between A and C. Now, arcs can be described in two main forms, either a minor arc or a major arc. Every circle, if I were to draw a central angle, would have a minor arc and a major arc. The minor arc is the arc measure whose points are on or in the interior of the central angle. Okay, and the major arc is everything else of the circle. Okay, so we have minor arc AC, and we use this way to show that arc AC, and we talk about the measure of arc AC being equal to the measure of the central angle. The major arc would be called ADC, or CAD, or CDA, I'm sorry, CDA or ADC. We have to use a third point over here to indicate a major arc so we don't confuse it with the minor arc. That is equal to 360 minus the measure of that central angle. Now, if the arc is formed by a diameter of the circle, we call that arc a semicircle. So the measure of semicircle, EFG, is 180 degrees. Notice we use 3 letters to describe a semicircle and a major arc. A minor arc only uses 2 letters. Here's a little helpful hint in writing math. Minor arcs may be named by only 2 points. Major arcs and semicircles must be named by using 3 points. So let's take a look at example 1. This circle graph shows the types of grass planted in the yards of one neighborhood. They want you to find the measure of angle or of arc KLF. Let's look at KLF. KLF is what we would consider a major arc. Okay, it's formed by the central angle KJF. And since they use 3 letters, we know it's a major arc. This arc represents the part of this circle graph representing centipede grass, which is 65% of the circle. So to find the measure of this, a full circle measures 360 degrees. We're just going to take 65% of 360 degrees. And to do that, we take 0.65 and multiply by 360. And if we do 0.65 times 360, we get 234 degrees for the measure of major arc KLF. So we need to talk about adjacent arcs. Adjacent arcs are arcs of the same circle that intersect at exactly 1 point. So in this example, RS and ST, arcs RS and arc ST, are adjacent arcs. Now, adjacent arcs are like adjacent segments in that their measures would add up to the total. So we have our arc addition postulate. The measure of arc ABC is the sum of the measures of arcs AB and BC separately. So let's take a look at example 2 using our arc addition postulate. Here's what we're told to find. They want us to find the measure of arc BD, which is this arc. And we aren't given any of these angle measures except we're given parts of the angle measures here. We know that the angle measure of AFE is 97.4 and EFD is 52 degrees. Well, keep in mind all of these arcs should add up to 360. Okay. Also, we have intersecting diameters BE and AC. So to find the arc measure for BD, which is the sum of these two parts, we need to find the measure of arc BC and add the measure of arc CD. Now, BC, you'll notice, is formed by the intersecting lines AC and BE, so we have vertical angles. So this is also 97.4 degrees. That means the measure of arc BC is 97.4 degrees. Now we just need to find the measure of arc CD. Well, in looking at that, you'll notice that arc AEC is a semicircle. So if I were to add 97.4 and 52 and take that away from 180, we would get the measure of arc CD. So why don't you take a moment to go ahead and do that calculation. When you are ready to continue, click play, and we'll see what we get for our final answer. Alright, we get that the measure of arc CD is 30.6. When you subtract these two from 180, we get 30.6. So if I add 97.4 degrees and 30.6 degrees, we should get a total of 128 degrees for our measure of arc BD. Why don't you take a few moments, pause the video, and see if you can do part B on your own. When you're ready to continue, click play and we'll check our progress. Alright, number 1, the first part of B is to find the measure of angle JKL. Well, we know that JKL is formed by arcs JK and KL. So JK is a vertical angle with vertical arc of vertical angles with arc MN. So if this is 25 degrees, this is 25 degrees. And arc KL, we're going to take 180 degrees minus the 40 and 25 here, or 180 minus 65, and get 115. So when I add those together, I get 140 degrees. Now for the measure of arc LJN, and that order is important, it tells you how to follow around the circle. We're actually taking LKJ, which is the same as JKL, and we're adding arc JN to that. So we're going to take the 140 we just found plus this arc. Well, this arc we take 180 for our semicircle KJN, or KJN, and subtract the 25, and we get 155 for that part. So if I add 155 plus 140, I get 295 degrees for the measure of arc LJN. Okay, let's talk about our next vocabulary term. Within a circle or congruent circles, we could have congruent arcs. And congruent arcs are two arcs that have the same measure. So in this circle, we have arc ST with the central angle x degrees. That would be congruent to arc UV with a central angle also of x degrees. And we have some theorems that go along with that. Here are the three main characteristics of congruent arcs. In a circle or congruent circles, congruent central angles will have congruent chords. Okay, we have our chords that go along with these arcs. So if I know these angles are congruent, I know chord DE and chord BC are congruent. And if I have congruent chords, then I know the arcs are congruent. So if I know these chords are congruent, I know the arcs are congruent. So if I know they're congruent angles, that tells me they have congruent chords, and if they have congruent chords, that tells me they have congruent arcs. So I can say that if I have congruent arcs, then the central angles are also congruent. So let's try example 3. We need to find each of these measures in each of these examples. We have one circle. We have chords TV and SW that are congruent. They're marked as congruent by those markings. And that tells us the arc measure SW is 7n plus 11 degrees. and the arc measure for TV is 9n minus 11 degrees, so I can set those two expressions equal because the arcs are congruent. Since these chords are congruent, I can say the measure of arc TV equals the measure of arc SW, so I can plug in those values. 9n minus 11 equals 7n plus 11. Why don't you take a few moments, solve this equation for n, and then we'll plug it back in and find the measure of arc SW or WS. Those are the same thing. Alright, if you need any more time, pause the video. Otherwise, these are the results you should get. Alright, when we solve this equation for n, by subtracting 7n from both sides and adding 11 to both sides, n equals 11. So we can plug that in for this expression. 7 times 11 plus 11 is 88 degrees. So the measure of arc WS, or SW, is 88 degrees. Let's take a look at part B. Here we have congruent central angles DCG and NJM because these are congruent circles. So we can find chord length NM because I know if central angles are congruent, then these chords are congruent. So we can set up these as congruent segments so they have equal length. So I know DG equals NM. So we can set up this equation. 14t minus 26 equals 5t plus 1. Once again, solve that equation for t and then plug it back in to find your result for the length of nm. Alright, here's what we should get. If we set these values equal to each other and solve for t, t is 3. When we plug t back in for nm, 5t plus 1, we get 16. Alright, we do have a few more theorems in this lesson we need to take a look at. In a circle, if a radius or a diameter is perpendicular to a chord, then it bisects that chord. So if we know this is a right angle, we can conclude that CD bisects segment EF and it bisects its arc. So it bisects EF. So these small arcs are congruent. These small chords, or small segments of the chord, are congruent. Similarly, we know if a perpendicular bisector of a chord is given, then we know it's a radius or diameter. It's kind of the converse of this theorem. So let's take a look at this last example using that fact. Here's what we are given. We are given that RM is a radius and it is perpendicular to chord NP. So we know that it bisects chord NP. We need to find the length of chord NP, and here's how we can do this. Because we have a right angle here, a radius is any segment that connects the center to any point on the circle. So I can draw this as my radius. I could also call this my radius. So Rn is equal to Rm, which is equal to Rp. Those are all radii of this circle. They give me this segment, Rs, is 8, and Ms is 9. Now, the reason that helps me is because I can find the radius now. 8 plus 9 is 17. So I know the radius of my circle is 17, so I can label this one as 17. And what you notice is we get right triangles where the hypotenuse is 17, one leg is 8, so I can find the other leg. But our theorem we just talked about said that it bisects that chord. So whatever NS is also the same as NP. So is half of NP, I mean. NP is going to be the same as twice NS. So in order to find NP, I'm going to find NS first, using our Pythagorean theorem. I'm going to say RS squared plus NS squared equals RN squared. Let's plug in what we know. RS is 8. NS is what I'm looking for at the moment. And RN is 17. So take a moment or two and pause the video and solve for NS, and then we'll plug that back in to find NP. Alright, here's what we should get. NS gets us 15. So if NS is 15, PS is also 15, or NP is 2 times 15, which is 30 units. Alright, that concludes our notes for Lesson 2. If you have any questions, feel free to come in and talk during class. If you if you are comfortable, go ahead and start the worksheet that's attached with this assignment, and we will talk more about Lesson 11-2 in class.